I welcome you all on India's largest and number one e-learning educational platform, that is Gradeup. All the candidates who are joining me, just quickly confirm whether my audio and visual quality, everything is clear so that we can proceed with the session. Friends, today we are going to have another session for the post-gate guidance series where our only aim is to make all the efforts so that your preparation must continue. Your preparation should not stop. Whether your gate examination has gone well, whether your gate examination has not gone well, but your preparation should not stop. Your preparation should not discontinue, because if your examination has gone well, then you have to prepare for the next stages, whether you are going for MTech admissions or the PSU jobs. May God forbid if your gate examination has not gone well, then also there are number of exams lined up in the next coming 3-4 months, that is ISRO, BARC, Engineering Services Examination, and definitely next year also you have the opportunity to appear again in the gate examination. Once again, welcome to the session. Medha, Tuhin, how are you? Welcome to the session. So friends, with this aim, today we are going to understand the transmission line conductors in the power system. What are the types of transmission line conductors in the power system? But before I start the session, very important, I want you to understand what is the outcome of this session. Outcome of the session means if you are going to follow this session throughout 45 minutes, then what you are going to get finally, what is the result you are going to get out of that? My friend, today we are going to discuss the types of transmission line conductors, and within one framework you will have the complete picture story of different types of transmission line conductors when you are designing your transmission line for your power system. So just allow me to start the session. Yes, Venkat, hello, how are you? Welcome to the session. And everyone who is watching me live or recorded, do not forget to follow the LSS method. If you think that you are getting some value addition, if you are coming to the session with some aspiration that I am going to get today something value, then please like the session. And if you think that sir is telling something very interesting and it may be helpful for other students also, then do not forget to share this session with your friends and colleagues. And also, most important thing is, if you have not subscribed to the Gradeup Gate YouTube channel, do subscribe the channel. This is also very important. So Tuhin is saying, let's start. Vindeshwari, good evening beta, how are you? Welcome to the session. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh, 10 years teaching experience, completed MTech from IIT BYJU'S in 2010, written a couple of books, and these are my expert areas which I deal with my students. Friends, before we start the session, very important information for Vision 2022, which is one of the most comprehensive course by Team Gradeup for the GATE category. You are getting 850 plus hours of live classes, 8000 plus practice questions, 100 plus mock test, and 120 plus chapter wise study notes. For any further clarification, you can contact this number. My friend, Gradeup is offering you the February Mela offer. Number of times I have discussed this. Only 4-5 days are left, but let me tell you, these days are not important. Why? Because these coupons, Feb 50, they are limited coupons. The stock is limited kind of situation, okay? And my friend, now the Gradeup Super subscription has been structured in such a way that it meets all your requirements. For example, if you are preparing for Engineering Services 21, you can get the validity till October 21. This is the price bracket. If you want to go for GATE and ESE 2022, this is the validity period, this is the price bracket. And if you want to go for GATE and ESE 2023, then you can go for this validity. Tuhin Chakravarti is saying, which book you have written? Beta, Engineering Ethics book I have written in 2019. It is already in market. If you find the 2019 edition, Engineering Ethics 2019, if you type in Google, you will get my name. But 2020 edition, you will not get my name because I have left the institute. So my name has been removed from there. But that book, even if the 21st edition, if you are getting, that is also, most of the chapters are written by me. Every single word is written by me. Apart from that, I have written one book on power system that is expected to be launched in July this year. I am trying my level best. Apart from this, my friend, the Gradeup is going to conduct third GNST Gradeup National Scholarship Test, where you can win a lot of scholarship prizes also. And this is going to happen on 28th of February 2021, which is the Science Day. So Science Day, you are getting something special. Now let us talk about the transmission line conductors. Types of transmission line conductors. Types of transmission line conductors. Number one, single solid conductor. You all must be aware with little bit of this, but I will be telling you this in the form of a story. Power system book bit I have written, but that is not yet published. I have the hard copy, okay, the first copy I have, but that is not published, so you will not be able to get it. But this year I am trying, maybe up to July it is going to be published. Single solid conductor. Then you are having stranded conductors. Then you are having bundled conductors. Then you are having hollow conductor. Hollow conductor. So let us start the designing of your transmission line. Suppose you are a power system engineer and you have been given this responsibility that you have the authority and you decide what is going to be the type of your transmission line. The first and the most obvious choice is going to be single solid conductor. This single solid conductor is going to be something like this, and suppose there is some AC current passing through this conductor. Because this is the most obvious design you can have for your transmission line. There are some advantages and disadvantages. What are the Tuhin is saying, sir, upload in the internet so that we can download it. Okay, I will think of it. Okay, it may not be free of cost. Why I am saying it is not free of cost? Because कुछ ना कुछ तो रखना पड़ेगा ना, because there is some processing charges are there. ठीक है, और वो जो एक ब्रेक इवन होता है वहाँ तक ले जाकर कुछ देखना पड़ेगा. तो बिल्कुल फ्री ऑफ कॉस्ट तो बेटा नहीं हो सकता. But definitely I will think of this option that you are saying. Thank you so much for your suggestion, Tuhin. Now there are certain advantages and disadvantages of having a single solid conductor. Let us see what are the advantages. If you talk about the advantages, my friend, can you tell me what is the most important advantage? Number one, it is going to have mechanical strength is going to be extremely high. Comparatively, the mechanical strength is going to be high. My friend, if mechanical strength is going to be high for this type of design, you please try to understand what are the other advantages you are going to have. Suppose this is your transmission tower. This is your transmission tower. This is another tower. This is your cross arm. And suppose your conductor is like this. Conductor is like this. So this is going to be your sag. Okay. And this is going to be your ground clearance. This is going to be your ground clearance. Now when you are saying mechanical strength is high, it means what? Sag is going to be less? Yes or no? If mechanical strength is high, then sag is going to be less. If sag is going to be less, you can say ground clearance is going to be high. If this distance is going to be less, then this distance is going to be more. If ground clearance is more, then you can say number and height of towers, transmission towers is going to be less, and if this is going to be less, the cost of that power system is going to be less. Everybody just tell me in the comment section, are you able to follow this or not? Tell me in the comment section. You can use a lot of emoji options are there in the comment section of YouTube, that also you can use to express your emotions, to express your feelings, and tell me whether you are able to follow this or not. This is one of the most important advantage of using a single solid conductor, but there are some disadvantages also. What are the disadvantages? Can you tell me? The disadvantages are that there is going to be a skin effect, and this skin effect is not small, that needs to be. Rohin is asking why cost? Yeah, natural si baat hai. It is but natural. If you are having this type of sag in the transmission line conductor, you want more height of the transmission tower so that ground clearance can be maintained. Yes or no? And if the mechanical strength is less, sag is more, then you have more number of transmission towers. It means if sag is more, to maintain the ground clearance, the height and the number of towers are going to be increased. So definitely cost is going to be increased. This is natural. Now why you are getting skin effect? Let me just tell you why you are getting skin effect. See, there are a number of ways in which skin effect can be explained, but let me tell you the simplest way. Suppose this is the current passing through this conductor and this is AC current. If this is going to be AC current, the flux which is set up by this current is also going to be time dependent, because this AC means alternating quantity, alternating current, time dependent. So the flux because of this current is also going to be time dependent. And if you apply the right hand rule, what is the direction of flux? The direction of flux is going to be something like this. The direction of flux is going to be something like this, and this is time varying flux. The moment time varying flux is linked with any conductor, eddy currents are going to be induced to oblige the Lenz's law. What is Lenz's law? Lenz's law is effect opposes the cause. Effect opposes the cause. Are you able to follow this? If the time varying flux is going to link with any conductor, the eddy currents are going to be generated, and the direction of eddy currents are going to be such that they are going to oblige the Lenz's law, that is, the effect opposes the cause. It means in this part of the conductor, eddy currents are going to be induced. In this part of the conductor, eddy currents are going to be induced. And what is going to be the direction of these eddy currents? The direction of eddy currents will be such that if the flux is going in this direction into the plane of the screen, the eddy currents will be such that they will oppose this flux. They will generate a flux which opposes this flux. Apply the right hand thumb rule. It means the eddy current direction is going to be anti-clockwise here, anti-clockwise here. Similarly, this part of the transmission line conductor, the flux is coming out of the plane of the screen, so this eddy current's direction will be such that the flux which is produced by this eddy current should be into the plane of the screen, Apply the right hand thumb rule. It means this side, the current, eddy current, is going to have the direction like this, which is clockwise. If you see the main current direction and the direction of eddy currents, you will understand that there is a tendency in the AC current to concentrate near the surface of the conductor, so that there is a non-uniform current distribution. When there is non-uniform current distribution, my friend, what is happening? if you say RAC, why RAC? Because if AC current is present, what is going to be the resistance offered by this conductor? This is going to be rho L upon A electrical. What is this A electrical? This A electrical is the cross-sectional area only where current is present. When you are talking about DC, my friend, when you are talking about DC, in case of DC, the current is present like this. There is a uniform distribution of the current. So what is happening? The electrical area and the physical area of the conductor is going to be same. But when you are dealing with the AC current, my friend, the current is only concentrated in a small area near the surface of the conductor, and this area, dotted area, gives you A electrical. So you can understand, when the effective area where current is present has been reduced, the effective AC resistance has been increased. Everybody just tell me in the comment section, are you able to follow this or not? Are you getting this idea clear in your mind or not? There is one interesting question, that why this effect is called skin effect. My friend, this is the case you are dealing with the practical conductor. If it would have been an ideal conductor, the current will be only present on the skin of the conductor. That is why this effect is called skin effect. Everybody just tell me in the comment section, are you able to follow me or not? Extremely important thing we are discussing. So we have concluded that the most important disadvantage of using a single solid conductor is that skin effect is going to be very high. If skin effect is going to be very high, it means AC resistance is going to be more than DC resistance. If resistance is going to be more, my friend, I square R losses are going to be more. If I square R losses are going to be more, then the efficiency of power transmission is going to be less. Are you able to follow this? Now, to remove this disadvantage of skin effect, we are going to the next design, next type of transmission line conductor, that is stranded conductor. Stranded conductors. Stranded conductors. Now please try to understand the story about this stranded conductor. For the single solid conductor, you are having the design like this. For the stranded conductor, you are having the design like this. You are using smaller strands. These are strands, rather than using a single solid conductor. Now what is happening? Listen extremely carefully. Extremely carefully, please try to understand. When you are using smaller strands, what is happening? Skin effect is going to reduce. Skin effect is reduced. This is first point. Skin effect is reduced. If you want to know, if you want to understand why skin effect is reduced, then I will tell you, but if you know, then it is okay. We can leave that. But the most important part you have to understand, we are saying skin effect is reduced, not removed. Not removed. It means what? Skin effect is still present. Skin effect is still present, my friend. So this is one advantage, that skin effect is reduced, not removed. But what is the disadvantage, my friend? What is the disadvantage? The disadvantage is, my friend, number one, mechanical strength is reduced. Instead of using a single solid conductor, if you are using multiple strands, the mechanical strength is going to be less, so that sag is going to be more. If sag is going to be more, ground clearance is going to be less. If ground clearance is going to be less, then number and height of transmission towers is going to be more. So my friend, cost is going to be more. Cost is going to be more. Are you getting this idea clear in your mind or not? At least tell me in the comment section. If you don't comment, nothing is going to happen to him, beta. The problem is that you cannot remove it 100%. Still some skin effect is going to be present. Are you getting that? Because still there will be AC current flowing. AC current flowing, flux is time dependent, linking with the conductor. Definitely again eddy currents are generated. So again you are having that phenomena of a skin effect. But it is reduced. Why it is reduced? If you know the answer, then okay, I will not tell about that. But if you don't know, you can ask me in the comment section. I will tell you why it is removed. Otherwise, let us leave it. One thing is mechanical strength reduced. One disadvantage. Second disadvantage is when you are using strands, number of strands, my friend, the outer surface has become irregular. The outer surface has become irregular. When outer surface has become irregular, my friend, at the sharp corners, the electric field stress is going to be very high. And if electric field stress is going to be very high, corona loss is going to be more. Corona loss is going to be more. So the second problem, second disadvantage you are getting because of using the standard conductor is that corona is going to be increased. Corona is going to be increased. And again, if corona is going to be increased, corona loss is going to be increased, the efficiency of transmission is going to be reduced. When we are using the standard conductor, we have achieved one advantage, that is skin effect is reduced. But at the same time, we are getting two disadvantages. Mechanical strength reduced and corona effect increase. Corona phenomena increase. Corona loss increase. So we have to find solution for these two problems. The solution for the first problem, that is the mechanical strength, what we are doing, when you talk about the standard conductors, my friend, standard conductors you can divide into two categories. One is homogeneous conductors. One is homogeneous standard conductor and another one is non-homogeneous standard conductor. What is the meaning of saying that it is a homogeneous strand? Homogeneous standard conductor means, suppose if you have a standard conductor like this, then all the strands are of same conductor material. For example, the best example is, suppose all the strands are of aluminium, so you are having AAC, that we are calling as all aluminium conductors. All aluminium conductors. Everybody just tell me in the comment section, are you able to follow this or not? Non-homogeneous standard conductor, my friend, when you are saying skin effect is reduced but not removed, it means some skin effect is still present. Skin effect present means the core strand is not going to have any significant current. So the non-homogeneous standard conductor is saying that you remove this core strand from this, and instead of this aluminium strand you place a steel strand. For example, if you are having a standard conductor like this, now this core we are using as steel because no significant current is going to flow from this because of the skin effect, and other strand we are using of aluminium. This type of conductor we are calling as ACSR. What is ACSR? ACSR is steel reinforced aluminium conductor. When you are using the steel strand, what is happening? By using the steel strand, actually you are increasing the mechanical strength. So by using ACSR conductors, you have removed the first problem, that is the mechanical strength reduced. By putting that steel strand in place of the aluminum core strand, you are getting increased mechanical strength. Everybody just tell me in the comment section, are you able to follow this or not? Now let me just give you some more information about the stranded conductors. Some more information about the stranded conductors. The first one is pattern of strands. What is the pattern of strands? It is going to be 1, 6, 12, 18, 24, 30, 36 and so on. It means apart from the core strand, whether it is homogeneous or non-homogeneous, whether it is homogeneous or non-homogeneous, my friend, it is going to have first layer. This is called the first layer, and this first layer we are assuming as core strand. After this, we are having the next layers where the strands are going to be in the multiples of 6, in the multiples of 6, that is 6, 12, 18, 24 and so on. After that, you are having the diameter of stranded conductor. When we say diameter of the stranded conductor, what do we mean? Suppose this is a stranded conductor, and suppose you want to find its overall diameter. That overall diameter we are defining as D. Very easily you can write this is going to be 3D, where D is the individual strand diameter. And you have a formula also, that is 2n minus 1 D. If you see how many layers are present in this stranded conductor, this is first layer and this is second layer. First layer is core strand, and after that second layer it is having 6 strands. So you have to put, for example, n is equal to 2. So you will be getting D is equal to 3D. D is equal to 3D. Here the values of n you can range from 1, 2 and so on. Everybody just tell me in the comment section, are you able to follow this or not? Extremely simple, but extremely important also. Third information is number of strands, total number of strands. Total number of strands, my friend, we are defining as capital N is equal to 3n square minus 3n plus 1. You can put n is equal to 1, 2, 3 and so on. This n give you the total number of strands. The fourth information is representation, and this is especially for ACSR conductors. For ACSR conductors representation, you are having two numbers x oblique y. If x is greater than y, then x is number of aluminium strands and y is number of steel strands. Otherwise, vice versa. Vice versa. It means whenever you are having an ACSR conductor representation by two numbers separated by this slash, then the lesser number of strands are going to represent the steel strands, because steel strands are there not for conduction but for increasing the mechanical strength. And the more number of strands, they will represent the aluminium strands, because aluminium strands are there for conducting the current. Are you able to follow me this? Follow me in this? Yes, Medha, Pragya, I hope you are getting this. Everybody just tell me, are you able to follow this or not? Is it clear? So this is all about the stranded conductors. Now the next one is bundled conductors. Why we are having bundled conductors? Can you tell me what is the reason? why we are having the bundled conductors. After the stranded conductors, we are going to the bundled conductors. The reason is we want to reduce the corona. Corona phenomena, if you want to reduce, then you have to reduce the electric field stress at the surface of the conductor. How you are going to reduce the electric field stress at the surface of the conductor? Please listen very properly. What we are doing, one single conductor, we are going to divide into number of smaller size subconductors. These we are calling as subconductors, and we are giving them some spacing. Some spacing is given to them. And what is the purpose? The purpose is that we want to increase the GMR. We want to increase the GMR. Suppose this original conductor radius is R and these subconductor radius is RB. Now what is happening? Instead of using one single conductor, you are using smaller size conductors, subconductors, and giving them some spacing. So what is happening? Current is divided. Current divided means charge divided. Charge divided means charge density divided. Charge density divided means electric field stress at the surface of the conductor is reduced. In other way, you can write the electric field stress at the surface of the conductor is given as V phase upon GMR ln GMD upon GMR. Is it clear? Are you getting that? Now this is logarithmic, so this effect we are not taking into account, but if you are increasing GMR, this electric field stress is going to be reduced. So ultimately corona loss or corona phenomena is going to be reduced. This is what we wanted. If you see this construction, if there is voltage V and I, here the voltage is going to remain same because all these subconductors are connected in parallel, but the current is going to be divided like this, I1, I2 and so on to IN. If you apply the Kirchhoff's current law, you can write I is equal to I1 plus I2 plus ... plus IN. And you know current is defined as current density multiplied by the cross-sectional area, and you know current density is constant for transmission line. Why it is constant for transmission line? Because load tappings are not allowed. You cannot connect load to the transmission line directly. You can connect load to the distribution part, not the transmission part in general. So we are taking the current density constant. If current density is constant, we can write current is directly proportional to the cross-sectional area. This cross-sectional area you can write as pi r square. So you can write this current as being directly proportional to r square. So what I am going to do, I am going to transform this equation in terms of the radius. And what I am going to get, this is going to be r square and this is going to be r1 square, r2 square up to rn square. These are the radius of all the individual subconductors in the bundled conductor. If all the subconductors are having the same radius, then I can write it as n times rb square, and this is r square. From here you can say rb is r upon under root n. So this is how, if you know the number of subconductors in the bundled conductor, you can find their individual radius also. Everybody just tell me in the comment section. Everybody just raise your hands if you are able to follow this. So this is the story of bundled conductors, my friend. Now let us talk about the hollow conductor. The concept of hollow conductors is basically, if skin effect is going to be present, then we know that there is no significant current present in the core strand. Are you able to follow this? Are you able to follow this? So there is one company whose name is Anaconda. This is the name of the company, and they have given one construction which we are calling as Anaconda Conductors, and this is very similar to the Discovery Channel Anaconda, which is something like this. At the periphery of this, number of strands you are using in such a way so that if no significant current is present in the core, the hollow conductor can be used so that there is a saving in the material. And this is the story about the types of transmission line conductors. So this is the complete story. If you have any doubt, you can ask me. Otherwise, let me just conclude the session. But before I conclude the session, let me just tell you about this series. Daily 10 p.m. in the night, I am dealing with important concepts of power system that you can join on the Gradeup Gate YouTube channel. Apart from this, this is I am having on the Gradeup Gate YouTube channel. Okay. Apart from this, I am having two sessions, one at 1 p.m. and one at 4 p.m. One at 1 p.m., one at 4 p.m. 1 p.m. I am dealing with machines, and 4 p.m. I am dealing with again power system. But these sessions we are having on the Gradeup app. So if you want, you can join them. Is it clear, everybody? Just tell me in the comment section. Oh my God. Suman, Lata, how are you? Welcome to the session. Thank you, thank you, thank you. So friends, thank you so much for your time. But before I conclude the session, let me just tell you about the faculties in the electrical department who are going to mentor you in the next coming preparation cycle, and you must be having your favorite faculty in the team Gradeup. My friend, these are the results we have produced over the years, and 2020 has been a landmark year when more than 60 plus Gradeup students have secured under 100 rank, and you could be the next one in this frame next year. My friend, if you talk about the Gradeup Super subscription, already discussed one subscription which gives you access to all the structured live courses and all the online mock test series under the green card. For any further clarification, you can contact this number, and I hope you will be assisted positively. Now, in one shot, let us try to understand what is this Gradeup Super subscription. My friend, it gives you unlimited access to all the structured live courses and mock test. So you will be getting structured live courses, complete doubt resolution, performance and report card, expert faculty, and full syllabus coverage. Sir, could you please upload those in YouTube channel? See, this is not in my hand, Vindeshri Thota. What you can do, let me just tell you. The video that you are watching on YouTube, there is a link in the description. अब वो बहुत सारे बच्चों को समझ में नहीं आता है कि लिंक तक पहुंचना कैसे है. तो आप जो वीडियो देख रहे हैं, इस वीडियो के नीचे एक वी का साइन होगा, छोटा सा ऑप्शन होगा, और उसमें क्या क्या डिटेल्स हैं उसको पढ़ने का. When you click on that button, there will be lot of description. For that description, you will be getting a link to directly route you towards the Gradeup app, or you can go to the my profile on the Gradeup app. You can follow me on the Gradeup app so that you do not miss any of my sessions, and you will be getting notifications for all my sessions. Okay, Vindeshri. Hi Shubha, how are you? Welcome to the session. Welcome everybody. So friends, this is all from my side. Thank you so much for watching me live, and I will be waiting for you tomorrow. What is the timing? Yes, so that you remember it. What is the timing? Yes. 10 p.m. in the night and 1 p.m. and 4 p.m. in the afternoon. I will be waiting for you. Thank you, Prakhar. Thank you so much, all of you. Take care of yourself, and do not forget to join me again tomorrow to understand the basic concepts of power system and machine. Thank you so much. Take care of yourself. Practice smart, score better. Go Gradeup. Thank you so much. Thank you everybody. Take care. Thank you.